So before we get into the demonstration, I'd like to share a little bit on what we've seen in the industry. So today, consumers are demanding more broadband products, and communication service providers have a variety of ways that they can deliver those broadband services. So CSPs need to be more strategic and provide to their planners and engineers the tools to be able to plan for the right technology in the right location at the right time. With the proper GIS tools, communication service providers can optimize their network rollouts and assets. ArcGIS with the utility network provides a complete GIS for planning and managing all types of communication networks, from the inside plant to the outside distribution network, supporting GPON and fiber to everything and anything architectures, while also supporting copper, coax, and hybrid networks. And of course, the ever-evolving wireless networks, whether it's mobile or fixed. So now, let's jump into ArcGIS and see how a complete network and connectivity model for communications can optimize the network rollout process. So with a complete GIS, we can plan communication networks and optimize network build-out, whether it's fixed line or wireless. Here in our map, we can see all of our fiber assets as well as our wireless towers being managed by the utility network. We've got a new business that is requesting broadband services, but it looks like they're quite a bit off net of our existing fiber network. So what we want to do is plan for a new fiber extension to this business and start to estimate the possible cost. Using the network planning optimization tools within ArcGIS, let's find the least cost fiber route to deliver that broadband service to this business customer. So first, I want to select our business location. Then, I want to select any of the assets and features within our telecom utility network that we potentially want to route back to. In this case, our manholes. Now, as a network planner, I may also want to see other business opportunities along this route that we could also offer this broadband service to. So let's return all businesses within 200 feet of this proposed route. Now, as this tool runs, what it'll do is it'll go into the utility network and locate all of the manholes. Then it'll find the manhole that is the closest to our business that has available network capacity that we can tap into. Then the route will be optimized based off of that least cost path. And finally, all of the business opportunities that fall within 200 feet of that fiber route will be returned. So here we can see that proposed fiber route. And selecting it will then show us the estimated cost to build it, as well as the total length of that fiber route, which we can see in the pop-up on the right-hand side. We also see all of those other business opportunities along the route that we potentially could sell our business services to. Now, using the same GIS application, I can also qualify this business for fixed wireless to see if it is a cheaper alternative than building out fiber to them. Here, I've got a 3D wireless planning map that I can drag alongside our 2D fiber planning map. Now, looking at the location of our new business prospect, it looks like that they fall in the green coverage area of our existing 5G small cells downtown. But let's actually go ahead and take a look at our fixed wireless assessment. In 3D, we can now see the business off in the distance. We also see our existing 5G rooftop antenna. Using the visibility and line of sight tools within ArcGIS, we can start to quickly qualify this business for fixed wireless service. Running these 3D tools, we can now see that our targeted building, our new business op, can receive this fixed wireless service. Everything in green has clear line of sight, while everything in red has an obstructed view. We could even add to these tools clutter data, look at other obstructions obtained from LiDAR data, and even start to model Fresnel zone as well as other spectrum frequencies. Now, before I fully qualify this building for receiving fixed wireless service, what I want to do is run a connected trace to figure out which of our central offices is the closest. This way, I can start to calculate the possible latency for providing this fixed wireless service. So, to start my connected trace, what I'm going to do is add a 5G receiver to the side of our business prospects building. Adding this rooftop structure also adds the necessary antenna equipment and network topology directly into our versioned database. You'll see once I add the point on the left-hand side that it appears in our 3D view as well. So the next thing that we want to do is we'll want to set up an association or connection between our original receiver on top of the roof and our original transmitter on top of the roof and our new antenna receiver on the business building. So to do that, I'll leverage the utility network and create a connectivity association. First, I'll select the antenna on our rooftop, existing 5G tower, and then I'll select our new receiver. And we'll create this association. Now I want to save my edits and then validate our network topology and connectivity. So now that we've created that connectivity, we can then start to view the association between that new receiver location and the original 5G transmitter. Okay, so now that we have a connected network, let's run that connected trace. First, starting at the business location, running through our wireless network to our 5G antenna, and then through the fiber network to locate that nearest central office. To do this, I've set up a nearest central office trace. And we'll go ahead and run this. So we see that the trace has been completed. And if we go take a look at what has been selected in our map from the trace, we have one structure boundary that has been selected. Now if we go zoom to the selection, it'll take us right to that nearest central office. And since we are using the utility network to manage all of our network information, we can easily start to view the inside plant world. So let's go back to our utility network and display our inside plant. This lets us see all of the floors, rooms, racks, patches, and other equipment within our central office. So now that we know our nearest central office, we know the fiber route that our antenna will take to get there, I can start to calculate the estimated latency and figure out if providing fixed wireless to our new business prospect is a cheaper and also viable option for delivering our broadband services.